Okay, just a quick look at the fuel pump. Here you have an electrical fuel pump. Before you had a mechanical fuel pump. The fuel pump obviously is in the fuel tank. Now you have two lines over here. The red line represents the pressure line. As you can see, the fuel coming, here's the inlet where you fill the fuel into the fuel tank. This is the pressurized line. So when you put the car and you start the ignition switch in the run position, not the start position, the run position, already you should have pressure. Depending on the fuel, and depending on the electronic fuel systems, that's the pressure will be indicated by that. So let's say for GMs, where they have something called a poppet nozzle going into the intake manifold, they need about 40 psi. Now, some even need 60 psi to start. So it depends on the system and the fuel needed to act, obviously, for the fuel injectors. So therefore, fuel goes in here, and it goes into this injector that we just spoke about, where it sprays the fuel. Comes back over here to the return line, whatever's not used. So therefore, you see these are flexible hoses. When you go around corners, they have to be flexible. One. There is a pressure regulator that we'll get to later on. But if you want to measure fuel pressure, like I just said, you put in the run position, you should be building up already pressure. The place to put it is right here, after the fuel filter. So, the fuel filter is here, over here, before the fuel filter, after the fuel filter, fuel pressure is over here, or sometimes you have something called a Schrader valve by the engine where you can measure fuel pressure much easier. But this is just an overall view. What I wanted to talk about was something over here that I forgot to talk about, which is electric cars. And electric cars, and the one that I didn't talk about, sometimes you have all electric cars where you have a battery pack, front and the back, and you have to charge it for many hours. You have something, the Prius, popular car, which is hybrid, meaning it has both electric and gasoline engine. So therefore, you have the both best of both worlds. And this is over 20 years ago. A good car, not the best. Now let's go to something that somebody asked me a comment on about this system that I showed yesterday. We're going to have to make it a little clearer. He said he was confused about inputs and outputs and what's going on. So let's try to clarify. Sensors are all over. In the engine, outside of the engine, in the exhaust, outside of the exhaust, in the airflow system. We have to distinguish between burned air and unburned air. Combustion is the process of burning, meaning we burn the airflow ratio. Now, over here you have air coming in. This is indicating, or the symbol for the air filter, which is a paper filter to take away dirt. We don't want any dirt coming into the engine. So therefore, there is sensors, mass airflow sensor, and intake air temperature. We have to know how much air is making its way into the engine. That's in grams per second. So the air is flowing into the intake manifold. Now, how much air? That's how we have a sensor. Now, where would be a good place to put the mass airflow sensor? Before the air filter or after the air filter? First of all, where are you going to put the mass airflow sensor? If mass airflow sensor dictates to the computer how much air in grams per second is being drawn, where would we put such a sensor to dictate that? Will we put it here in the engine? or will we put it here? Now let's go both ways. If we put a mass airflow sensor over here, what's in the engine? The air-fuel ratio that's being burned, combustion process. That's not going to help us. We want to know air before it gets to the engine to be burned. So therefore, after the air filter, here's the air filter cleaning up the air, right? Make sure you get clean air into the engine. Therefore, the best place would be over here, right after the air filter. So obviously, if you're going to have a problem where the air filter is clogged or obviously needs to be replaced, you can have less air coming in. Less air will dictate to the computer less fuel. It goes hand in hand. So therefore, make sure every 20,000 miles or so, check at least the air filter to change it. So now we know the mass airflow sensor should be in this vicinity over here. Why? Because this is unburned air. This is pure air just being drawn in. So that's a good place to put a sensor. What about the temperature of the sensor? The comment was asked, where would you put these sensors or why would we put these sensors? So let's try to address the issues. Mass airflow sensor is here after the airflow, right? Mass airflow. What about intake air temperature? Intake air temperature sensor will tell us if it's cold air, if it's January, or if it's July, hot air. The colder, the more denser the air. The more denser the air, the more you need more fuel from the fuel injectors to put more into the cylinders. Higher RPM. Therefore, what would be a good place? Right here also. Intake air temperature and mass airflow sensor. If you find one, you'll find the other. Sometimes, like I went over the schematics, they're in one connector. They're in one unit together, like the Fords. Sometimes they're two apart. How many wires? 3 wires here and 2 wires here. Not to get too technical, we went over that. But anyway, so this is a good place to put these sensors. Okay? Then you have the throttle body. What am I doing with the throttle body? The gas pedal that you're opening, that you're actually pressing, you're moving this. When you're doing that, you're allowing more air. Instead of this position, it'll be in the open position. Therefore, this throttle plate will change as you step on the gas pedal. So if it's a gas pedal, why is it called the gas pedal for letting air in? It should be called the air pedal. Well, indirectly, when we let more air in, the computer will adjust the fuel injectors for more fuel. So indirectly, we are allowing more gas, even though we're stepping on the gas pedal, which is allowing more air in. So now we have the two sensors over here. We're stepping on this is connected to a cable through your gas pedal through this throttle body. Nowadays it's electric, but besides the point, we're allowing more air to come in, unburned air. That's number one. Criteria number one. Let me try to get this out of this. Criteria number one. We need that to happen. After all these things happen, now how do I know how much this is being opened? A TPS sensor. If I have to know how much this is being opened, the throttle plate, and how much you are stepping on the gas pedal, where am I going to put a TPS sensor? Oops, TPS sensor. Right on the throttle body. Doesn't it make sense? It should be right here. So therefore, we have these sensors right here already in the air induct system. Over here. Unburned air. Unburned. First, we want to know how much air is being drawn in. How much and the temperature of it. They all go into here as input. Make believe this is an input. Okay? Now, what comes next? The fuel injectors. These are fuel injectors on the rails. That's why I started off that one, the beginning of the video, with that premise of the fuel. First comes air. You're stepping on that gas pedal. You're allowing air to be drawn in. Then the computer says, I have to open up these fuel injectors. But how much? How much? Depends on how much air. When fuel, through these fuel rails, when fuel is being drawn into this engine, doesn't matter if it's a 4-cylinder, doesn't matter if it's 8, doesn't matter if it's 6. You need air and fuel. That combination is the air-fuel ratio. What do I need next? I need a spark plug. Spark plug will be here, right? As you can see over here, spark plug. And when you have the spark plug over here, then, actually the spark plug is over here. These are the valves. These are the valves. And these are, as you can see over here, these are actually the exhaust, the output. This is the input. So in this, I guess pictorial, whatever it is, the spark will allow the piston going up, which compresses that high temperature and high pressure, with that spark to explode. It's like an explosion. And that cylinder will now go, the piston, will go now in the downward direction. It goes up to squeeze it as much as it can. More pressure, more temperature, the better the compression. And then it will go down, and then it will force that piston to go down. Now, the exhaust comes out. Whatever is left from the air-fuel ratio, unburned fuel, whatever comes out there, burn fuel, everything of exhaust, it'll come out here. This is the exhaust. This is the exhaust. Let's make believe this is a V6, V8. This is the exhaust. Comes out here. They come out here. Catalytic converter. Now, the gases that come out, hydrocarbons, carbon monoxide, carbon dioxide, oxides of nitrogen, oxygen, obviously. We want to know how much is coming out, how much was burned. And this is what I did the video yesterday. Therefore, we want to know how much is being burned. We're going to have oxygen sensors. Where's the logical place to put oxygen sensors? Not over here where it's not burned. Put it over here at the output after the combustion has occurred. So we're going to put oxygen sensors at the exhaust. Oxygen sensors at the exhaust. 2 banks, 1 bank, 2 bank they refer to. We're going to put a pre-catalytic converter. And we're going to put it after the catalytic converter to see how well he cleaned off these pollutants that I just mentioned before. We want to know how the process went, how much was burned from the air-fuel mixture, and we want to know how much he did his job for hydrocarbons, like I just said, and all these things, and all these pollutants I just mentioned. So where are we going to put the oxygen sensors? Here, 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 here. Any exhaust in the olden days, you always saw it on the Hondas or the Toyotas, that the oxygen sensor was right there by the exhaust, right in front of you to pick up the hood. Now, obviously, which is the hottest part? Which is the hottest part? Is it here? No. The hottest part is what comes out after the combustion process, which is the exhaust. This is why you always see the bolts are rusted. Heat creates rust. So you know if you have to take out something, an exhaust shield or a catalytic converter, those bolts will be rusted. Time to get the penetrator or the torch ready. You're in for a big job. So therefore, the oxygen sensors, mass airflow sensor, all these things will tell the computer, like we said yesterday, how much air is being drawn in, how much is being burned from the air-fuel ratio, the ignition timing, the spark, all these things are by computer. Now, we just mentioned all these things over here. Mass airflow sensor, intake time. Are these sensors giving information to the computer, or is the computer giving information to them? All these sensors are giving information to the computer. They are transmitting what they see to the computer. The computer will then turn these on and off more. Will it will change ignition timing. Sometimes a few degrees before the piston goes all the way up, 40 degrees, 15 degrees, depending if you have pre-ignition. That's why you need a knock sensor. Sometimes you have little detonation, it's called, hot spots. You don't need the spark that fast. You have to retard it. You have to slow it down. All these things are crucial to the timing of the best combustion, best compression, best exhaust, best pollutants to be clean out, so you can pass on your emissions test for your inspection. Now, we just yesterday 14.7 parts of air to 1 part fuel. That's what the computer wants to adjust to. So, oxygen sensors 1, 2, let's say 3, 4. Sometimes even more than that. Do they give information to the computer, or is the computer giving information to them? They are giving information to the computer. How much oxygen content it sees. And we went over this yesterday, so I'm not going to go over detail about that. All these sensors that you see here, oxygen sensors, they give information. What will the computer control? The answer should be these fuel injectors. They will control the on time of these by something called pulse width modulation. I don't want to get too technical, but they will control these on times of these fuel injectors, either more fuel or less fuel, to try to get everything 14.7 to 1 part fuel. That's a great combination that gives us the proper pollutants and the proper levels. So therefore, keep in mind one thing. Unburned air over here. You will, if I want to find a mass airflow sensor for a Ford, for a Toyota, where am I going to look? Am I going to look here in the engine? No, I'm going to look over here. Now I want to find intake air temperature. Where am I going to look? Here, at the exhaust? Here. If I want to find oxygen sensors, where am I going to find them? Am I going to look for here, after the air filter? Am I going to find an oxygen sensor? Why put an oxygen sensor over there? It's unburned air. That's not going to help me. If I want to find oxygen sensors, I'm going to look at the exhaust, the output, after the burning process. Whatever was burned, whatever was not burned, we take it, and if there's vapor or exhaust, we put it right back to the engine. It's called EGRs and PCV valve and all these things. Vapor is to be returned from a charcoal canister. All these things have to be reburned. So therefore, not to make anything too technical, so if you want to find oxygen sensors, I go to the exhaust. If I want to find the fuel injectors, where am I going to find them? On the fuel rail. Find the fuel rail and you find the fuel injectors. So anyway, I hope this was a little more helpful and it cleared things up. Hopefully. Like I said, there's much more to be explained than just what I just said. I might try to simplify it, but it's much, much more complicated than anything you've ever seen. Believe me. So anyway, use this and try to absorb it. My channel is Joe Electronic Schematics for Auto. My other one, Automotive Electronic Schematics by Joseph. And you'll see videos of relays. I know there were relay problems. I got some comments. There were relay problems. Basically, in a relay, you have to go and about relays to go over it to make sure. The comment that I was, or the question I was asked, not the comment. 86 and 85 usually are the coil side, the control side. The 30 and the 87 is the load side. This goes to the load. And this one is horns. Could be the fuel pump, could be the starter motor, could be any motor, could be anything. So 30, as you can see over here, is 12 volts. That's 12 volts. 12 volts. 87 is the most important in this one because it tells you if this works, then this works. So now this is connected. This will be 12 volts. If I get 0, that means this is not working. This has not been energized, or this part of it has not been flipped. The switch has not been flipped. I have to see if I have 12 volts over here. Make sure the fuse is good. If I have 12 volts over here and I have 0, go to the relay. Now, unless you have a ground from a computer, if you have a ground from a computer giving this a ground, you have to make sure you get the ground from the computer to energize him. Another thing, this, in that example, instead of this going here to 87, 87 went to B+. 30 went to the load. So you know when 30 is going to be 12 volts? When this is flip-flopped, this is closed to 12 volts. It was just the opposite. So make sure how the configuration is. Sometimes it could be like this. 87 is down here. 30 is up here. But sometimes 30 can be down here. And 87 can go to the 12 volts. Keep that in mind. Anyway, thanks for the comments. Thanks for the questions. Try to get that much questions as I can. Thanks for watching.